Hello and welcome to a Saturn Online presentation of combustion heating basics. And sometimes it's a little intimidating or foreign when you first get into the energy business and have to look at different types of combustion heating devices. And so let's see if we can find some common elements in different types of heating devices and identify them and try to understand what they do. The three most basic types of elements in a combustion heating system are the burner, the heat exchanger, and the venting system. So burner, heat exchanger, and vent. And of course the burner is the thing that burns the fuel. And the heat exchanger is what the burner heats up. It's usually a piece of metal. It can be cast iron, it can be copper, it can be aluminized steel, and the flame heats up the heat exchanger. And the heat exchanger helps to keep the products of combustion separate from the air in the house. So the heat exchanger is part of a system inside the heating device that takes the heat from the flame and from the combustion gases, but directs the exhaust gases into the flue. So here the return air from the house or from the room, in the case that this would be a space heater, would go into the fan and be blown up near the metal heat exchanger, right alongside of the heat exchanger, and the air would pick up the heat from the heat exchanger and be either discharged into the room or discharged into the supply ductwork. Now, what happens inside the heat exchanger is that there's a burner, and the burner burns, and the burner is heating the heat exchanger through radiation and convection, because the hot gases convect up through here, and when they get up to the top, they come out of this exhaust vent, and those gases at that point are finished heating, and they go into the vent. At the exhaust side of the heat exchanger, up on top, we have a fan, and the fan either delivers the exhaust gases into a standard masonry chimney or a standard double wall metal chimney, or else it delivers it through a specialized vent horizontally through a sidewall. If it delivers it to a standard masonry or double wall metal vent, it's called fan assisted. And if it delivers the exhaust gases through the sidewall, through a horizontal vent, it's called a power vent. So we have a furnace, or this is a furnace or space heater, and it's moving air through it, picking up the heat from the heat exchanger. The heat exchanger's job is to transfer the heat to the air without mixing the air and the combustion gases. So we have a separation of the air and the combustion gases. Now let's look at a sectional boiler. This is a cast iron sectional boiler. We have these boxes, and they're made of cast iron, and they're full of water, and they have a manifold running through them so that they're all connected together. You know, water comes in one side and out the other side, moved by a pump, which is also called a circulator. We have a burner, a heat exchanger, and a venting system. And in this case, we have a barometric draft control. We don't have a fan here. We have an old-fashioned type of a venting system that has a barometric draft control. What the barometric draft control does is it keeps the draft steady. If we have wind blowing across the chimney, which is causing a tremendous updraft, we don't want that to affect the flame. And so the barometric draft control will open and let air in from the room to weaken the draft. Now, if the draft is is weak already, if there isn't much of a draft, then the door will remain closed. And if there's a strong downdraft, the barometric draft control will let the downdraft out this way rather than coming in and interfering with the flame. That's its purpose. So we would call this atmospheric draft, because the draft, which is the force that moves the exhaust gases up the chimney, is created just by the buoyancy of those gases. It's really created by the flame. The flame powers its own gases out of the house. It heats the gases, they become hot, they're lighter than air, and they shove their way up the chimney, and they create a force called draft. And the draft continues to cause the exhaust gases from the flame to go out the chimney. So this is a cast iron sectional boiler. We have water moving through the heat exchanger, picking up the heat from the flame, carrying it to the house. And we have an atmospheric chimney, a barometric draft control. That's one way of doing it, very common with oil heating. Now, here we have a different type of a boiler. We have a water tube boiler. We have a power burner, and the power burner has a fan in it. So it takes air in from the surrounding room, and it mixes it with the natural gas, or it mixes it with oil and blows it into this combustion chamber, and there's a vigorous flame in here, and the flame goes up through this coil of water and directly heats the water by way of the coil by radiation and convection. Radiation of the flame and convection of the gases. So this is a power burner, and the power burner, moves the combustion gases through the appliance and into the chimney. And in the chimney, we could either have another fan, or we could have a regular atmospheric chimney like a masonry chimney or a double wall metal chimney. Then let's look at a water heater, the way that a water heater works. A water heater is just another fire tube boiler. We have the flame down here. We have the combustion gases going up through here and through the draft diverter. Okay, a draft diverter is just an interruption in the flue pipe. This flue pipe ends right on top of the water heater, and then there's a device called a draft diverter that comes down. And what the draft diverter does, same thing that this barometric draft control did in kind of an emergency situation. If there was a downdraft, the downdraft is going to come out here. What we don't want is for it to come down and interfere with the flame or push the flame out of the firebox. Because when you push the flame out of the firebox, the flame can start a fire, and this actually happens on occasion. It's a common cause of fires. So this draft diverter is supposed to protect from that. And so again, we have a burner, and we have a heat exchanger, which is actually a tube going up through a tank of water. This is how we heat our domestic water with gas or propane. And so the heat exchanger is this flue pipe that goes right up through the center of a tank full of water. So the burner heats the tank by radiation on the bottom, and the flue gases heat the water in the tank by going up through this pipe. And when we get to the draft diverter here, besides diverting downdrafts, the draft diverter also lets air from the room into the chimney, just like the barometric draft control did, to kind of temper the draft. Because if the draft got too excessive here, the draft could either make the burner very inefficient by moving a tremendous amount of air through there, more air than we really need, or in certain cases it could actually pull the flame right off the burner. So that's why we have this flue is is not continuous. It's not connected together. There's an airspace up there. Now, this is a kind of an obsolete type of venting system, but we still find it everywhere. So got to be able to recognize it and know about it. All these three systems have three components in common. We have a burner, we have a heat exchanger, and we have a venting system. And it's, through this course and your other learning, you'll learn to recognize different types of heating equipment and the different types of burners, heat exchangers, and venting systems that they have.